Hello everyone. On Power System Technology. In our work, we often come across situations where a single wire is unable to carry sufficient current. So another wire is added in parallel to increase the current carrying capacity. As electricians, we all understand that wires with different cross-sectional areas cannot be used together. But why is that? Today we will perform an experiment to explain why it is not possible to parallel wires with different cross-sectional areas. Here we have taken two single-core hard wires manufactured by Zhejiang Yu and Tang Cable Manufacturing Company Limited. One with a cross-sectional area of 4 square millimeters, and the other with a cross-sectional area of 6 millimeters. Now we have connected the two wires in parallel and attached two identical clamp ammeters of the Victory brand to each wire. Next, we will apply a current to these parallel wires and measure how much current each wire carries using the ammeters. Let's start with a current of approximately 30 amperes, A, which is equal to the sum of the cross-sectional areas of the two wires. Let's adjust it slightly to around 35A. Now let's take a look at the readings on the ammeters. The 4 square MEP wire carries 16.3A, and the 6 square emitter wire carries 28, so the total current is around 36. 4 to 36, 5A on the other side. Let's increase the output current to approximately 60A. Normally, a 10 square millimeter wire is designed to carry a rated current of around 60A. Let's see if the current ratio of the two wires is similar to their cross-sectional area. Let's adjust the output current to try to make it exactly 60 AA. This adjustment is a bit difficult. Currently, it's 62 A. Let's take a look at the readings on these two ammeters. The 4 square medium wire carries 28A, and the 6 square monotone wire carries 34. 2 to 34. 3A. Let's touch the wires. The temperature hasn't changed much. At this point, the 4 square millimeter wire is already operating under overload, while the 6 square millimeter wire is still within its rated current range. This indicates that the 4 square millimeter wire carries a slightly higher current than the 6 square millimeter wire. Let's adjust the current to 100A and observe the current situation of both wires to see if the difference becomes more pronounced under overload conditions. After the wires are overloaded, they will heat up and their resistance will increase, resulting in poorer conductivity. Now at 100A, the 4 square millimeters, the 4 high wire carries 45, 6A, and the 6 square millimeter wire carries 56 6A. The current does not distribute ideally based on the cross-sectional area of the wires. From here we can see that when two wires are run in parallel, wires with different cross-sectional areas cannot be used in parallel, as it significantly reduces the current carrying capacity of the wire. Alright, that's it for this video. Thank you for watching, and feel free to comment, share, and follow us.